All right, so we have standard differential, November the 5th, 2020. So on the left, we have the function, and on the right, we have the derivative. So if we differentiate x to the n, that is a standard power derivative. So the power goes to the front and the power decreases by 1. All right. Now ax plus b raised to the power n. When you differentiate that, this is sort of like chain rule. Well, it is chain rule. And what we'd have to do is that we differentiate the outer function and then we multiply by the differential of the inside function. So the n goes to the front, the power decreases by n, and we multiply by the differential of the inside function. The inside function is ax plus b, and when we differentiate ax plus b, we're going to get a. So the final answer here would be an into what? Ax plus b raised to the n minus 1 power. When you differentiate e to the x, you're going to get back e to the x. When you differentiate e to the x, you're going to get back e to the x. If you differentiate e to the ax plus b, you're going to get back e to the ax plus b, and you have to multiply by the differential of the inside function. The inside function is ax plus b. When you differentiate ax plus b, you're going to get a. So our final answer is ae to the ax plus b. If you differentiate ln x, you're going to get 1 over x. And if, of course, everybody should remember that sorry, this should be ln x. Ln is the same as saying log to the base e. Does everybody remember that? Hello? Hello, everybody remembers that?
Yes.
Yes, sir.
So ln is log to the base e. If you differentiate ln x, you're going to get 1 over x. Now, if you differentiate ln ax plus b, so ln ax plus b is a composite function where the outer function is ln x, and the inner function is ax plus b. When you differentiate a composite function, you would use the chain rule, which is to differentiate the outer function. So if I have ln ax plus b, I can differentiate the outer function, which is to get 1 over ax plus b, and then multiply by the differential of the inside function. The inside function is ax plus b. When I differentiate ax plus b, I'm going to get a. And so my final answer would be a over ax plus b. When you differentiate sine, you're going to get what? Cos. If we differentiate cos, you're going to get minus sine. If we differentiate tan, you would get sec square x. Does anybody remember how to differentiate tan? How would you differentiate tan? If I give you, let us say, y is equal to tan x, how would you differentiate it? Well, it's okay, you don't have to tell me now. What I would do is I would say tan x is the same as saying sine x over cos x, and treat it as a product, sorry, as a, and differentiate it using the quotient rule. I would say that y is equal to tan x, which is sine x over cos x. And I think everybody should remember that tan x is the same as saying sine x over cos x. And I would differentiate it using the quotient rule. I hope you all remember the quotient rule. So you have what? Cosec, sorry, when you differentiate sec, you get what? Sec x tan x. When you differentiate sec x, you get minus sec x cot x. When you differentiate cot x, you'll get sec x minus sec x. I think it's actually minus sec squared x. I could be mistaken, but I think it's minus sec squared x, not sec x. If you differentiate arc sine, which is the same as saying sine inverse x, if you differentiate sine inverse x, let me remove that bracket. If you differentiate sine inverse x, it's 1 over the root of 1 minus x. If we differentiate cos inverse x, it's minus 1 over the root of 1 minus x squared. If we differentiate tan, arctan, or tan inverse, you get 1 over 1 plus x squared. And as I said, as we progress to the lesson, you will find out how to do this. And I did say initially, it would be good if we know how to do these things from first principle, if we know how to do it from scratch. The product rule says, if y is equal to u multiplied by v, where u and v are functions of x, the derivative of y is equal to uv is u multiplied by the differential of v plus v multiplied by the differential of u. I normally just say leave the first, differentiate the second, plus leave the second, differentiate the first. The quotient rule says if y is equal to u over v, where u and v are functions of x, the derivative of y would be v multiplied by du over dx minus u multiplied by dv over dx over v squared. All right, so these are the standard derivatives. And as we progress in the lesson, the ones that you don't know how to do from scratch, you will learn how to do it. I'm turning the page. All right, so what I want to show you now is how do we differentiate e to the x. And what you need to remember from the first page is that the differential of ln x, when you differentiate ln x, you got 1 over x. That's something you have to remember. All right, so I'm going to start by showing you how do we differentiate e to the x, or how do we show that the differential of e to the x is e to the x. All right, so I'm going to start by saying y is equal to e to the x. Now, the next thing I'm going to do is, all right, well, when you differentiate e to the x, when you differentiate e to the x with respect to x, you're going to get e to the x. And I'm going to show that that is the case. All right, so here I have y is equal to e to the x. What I'm going to do next is that I'm going to take ln from both sides. So log to the base n of y is equal to log to the base n of e to the x. All I did was found log to the base n of both sides. Here's a law of logarithms that you need to remember, that if you have log, let us say the log of a to the x is the same as saying x times the log of a. Do you agree? Help me, please.
Yes, sir.
If you want, you could make the base b, doesn't matter. So this is a law of logarithms that we can push the power to the front of the log. It's a law of logarithms. It means, therefore, that ln y is equal to x ln e. All right. Now, everybody should also remember that ln e is the same as saying log to the base e of e, which is equal to 1. So this is the same as saying ln y is equal to x times 1, which is x. Now I'm going to differentiate both sides with respect to x. I'm going to differentiate both sides with respect to x. When I differentiate ln y, remember from here, if I differentiate ln y, I'm going to get 1 over y. And I have to now multiply by the differential of y. When I differentiate y with respect to x, I'm going to get dy by dx. If you didn't understand that, don't worry about it too tough. When we do implicit differential, you'll understand fully. But what I did, when I differentiate ln y with respect to x, when I differentiate ln y, I'm going to get 1 over y. And when I differentiate y with respect to x, I get dy by dx. Now on the right-hand side, when I differentiate x with respect to x, I'm going to get 1. So now I'm going to bring this y over here. So now I have dy by dx is equal to y. But y is equal to what? E to the x from the very first statement. So it means that if I differentiate y, which is equal to e to the x, I'm going to get back e to the x. All right, look at it. Any issues?
No, sir.
All right. So all that was just designed to show is that if you differentiate e to the x, you're going to get back e to the x. All right, let's stop the video here. And